So I am super disappointed that I wasn't actually able to make a trip to Russia this time. I would have loved to have been in Moscow, but I'm very glad that the conference was still able to accommodate me online. And welcome to my talk on using TypeScript for infrastructure management. So this, even though this talk is about TypeScript, it's much more around the fact that using real languages are much more of a day-to-day usage of your infrastructure management than just DSLs or JSON or YAML, because I believe we've moved past that era, or we're very soon to move past that era, and I believe that we're starting, our infrastructure code is becoming more and more complex, that we need a little bit more logic in there, and some of those languages don't really accommodate that logic, and that's what a lot of this talk is about. So I'm going to say that right now there's a lot of people going through different transitions into the cloud. Okay, and there's like, and I'm not saying you go V1, V2, V3. There are a number of different transitions based on your business and based on your requirements or your maturity level inside your operations organization. So V1 would be the equivalent of picking up your data center and moving it to the cloud. So you would have traditional N-tier style architecture. So you'd have application web servers in a pool, you'd have database servers in a pool, and you probably have something like Puppet or Chef or Ansible managing these machines. They're very long lived, and you treat them very, very much like they're your pets. Okay, like you need to care for them, you need to love them, and you need lots of different things for them. And that's like what we would call like the first wave. And then that's as you're starting to explore the cloud. Then you have teams that are a little bit more, I'm going to say mature, because it's a maturity level really, where they're starting to experiment a little more. So maybe they're taking advantage of containers. Maybe they have a hybrid solution that they have some VMs, some container-based services. They're taking advantage of hosted services in there, maybe like some RDS web servers or Aurora web servers, or in Azure MySQL, or excuse me, MS SQL, whatever you need. And they're starting to like experiment with like observability using like tools like Honeycomb or Datadog and all these different things. So, you're starting to build this much more transitional style architecture. And then you have teams that are like the more mature teams, okay, where they have now what we call like modern architectures, like, you've heard terms like cloud native or microservice based architectures, or all these different things, where you're more than likely taking advantage of using containers, and containers using an orchestrator. So maybe Kubernetes, maybe HashiCorp Nomad, maybe Swarm, maybe Mesos, any of these different things. You're definitely taking advantage of like things like analytics patterns and observability patterns, and then maybe you're taking advantage of some serverless and all these different things. And you start to build this entirely different setup of all these different pieces. So traditionally, tooling in the infrastructure as code space is very good at V1 and V2 and are starting to get better at V3. So I work for a company called Pulumi. This is not a sales pitch. Everything I show you today is free. It is open source. I'm not suggesting that it's the only way of doing it. I'm suggesting that it is a way of doing it, and it's potentially a way that would fit with your workflow. So I work for a company called Pulumi, and we have actually attacked the cloud from the V3 scenario. So we've gone after the modern style architectures, the building of these modern building blocks, and the understanding of how all these different pieces come together. And that's what the examples that I'm going to show you today as we go through. Just to make sure everyone is on the same page, and it's super important that that's the case, is I'm going to talk about infrastructure as code a lot today. So a quick recap of what it is. It's a way of actually automating your infrastructure so that you remove these manual, error-prone ways of working. So clicking around on a console or writing bash scripts and a bash script that's non-idempotent and stuff like that. It allows you to get previews of your changes, and allows you to actually understand the visibility of what is going to change, excuse me. And why we would do it is it's automatable and it's repeated, which means it's idempotent. It's much faster to deploy because you can do some things in a script that would take 20 minutes or 30 minutes clicking around a console, and you could get it wrong. And more importantly, it's much more predictable because we understand the APIs that we're talking about. So it's not around actually just the writing of the code. It's about understanding why that it's the better way of working. Now at Pulumi, we believe we are modern infrastructure as code because we use real languages. Because of that, we can build real layers of abstraction, real APIs, real packages. So if you're in TypeScript, you can take advantage of the NPM ecosystem. If you're in Python, you can take advantage of the PyPy ecosystem, and so on and so forth. You can use your favorite tools in your IDEs, and I will show you the fact that I'm using an IDE today. We can take advantage of testing. Testing is an entirely different kettle of fish, and I could spend an entire talk around testing itself. But today I'm going to talk just much more around the basics and the workflows. And then we have our CLI, and it integrates into CI/CD workflows, and we audit all our changes. So where we differ is the fact that we're starting to take advantage of language ecosystems. So because we're taking advantage of language ecosystems and we can take advantage of everything inside that ecosystem, we believe that we're actually moving towards the era of infrastructure as software. So it was when I was introduced, it was said that I believe that the delivery of software is just as important as the creating of software itself. Now, for me, that is extremely, extremely important. It's why I build these tools on a day-to-day basis, because for years gone past, we have only really focused on actually writing the software, and its deployment mechanism and its hosting mechanisms were an afterthought, because we used to turn around to the ops teams and say 2 weeks before going live, I need a server, it's going to do this, and then of course it was a very big rush in order to get things working. So for me, it needs to be part of the same process, and it needs to be part of what we're building and what we're doing. Now Pulumi allows you to do it in a number of different layers. Okay, so firstly, it has the raw providers. Okay, so you can interact directly with AWS, Azure, GCP, Kubernetes, OpenStack, DigitalOcean, Datadog, Cloudflare, New Relic, and lots more. Because we have that, we have been able to develop a library of patterns, okay, across the top of it, which allows us to actually be a little bit more abstract in how we're developing and building our infrastructure. And then even based on those patterns and those libraries, we have actually published some best practice frameworks that will allow you to do things in a much simpler manner and using just the defaults that are specified by the cloud. So an example of that would be building a VPC. So a VPC is your own virtual private cloud in Amazon. Okay, so what you would need is you need the VPC itself, then you'd need the subnets, then you'd need the route tables, the routes, the route table associations, then you need an internet gateway, then you'd need a NAT gateway potentially if you need outbound access from private, and you need elastic IPs that go with those NAT gateways. And it has a lot of different pieces and a lot of different boilerplate. But in Pulumi, we've been able to wrap all of that code to make it super simple in one line of code. And I'm going to demo this in a little bit, because we believe that there are some people in the industry who don't need to care about those specific things. So like not infrastructure developers, but application developers, but people who need to deploy applications into the cloud, and they need a very fast way to do it, to be able to test what they're doing and actually be able to verify that their code is correct before they send pull requests. So we can build these frameworks and these practices for you. Now, I told you that it's code, and it's really important to say, because it's code, it fits into the entire code and language ecosystem. So we have our source code. You can read from GitHub, Atlassian, GitLab, VSTS, all the different source code systems that you want, because it's just code. Then we support JavaScript and TypeScript. These are our main. These were the first two languages that we supported in Pulumi, and that's actually why I'm talking about TypeScript today. Funny story about that. I hate JavaScript. I don't hate JavaScript. I'm joking, of course. I am not a fan of JavaScript, but when I started building infrastructure with TypeScript, I absolutely fell in love with it, because it's a very simple language in order to get up and running with, and it looks very easy to read and very easy to understand. Now, I am not a Python developer, I'm actually a Go developer, but yet I believe that doing the same thing in Go actually feels a slight bit more verbose. But of course, we also support the .NET ecosystem, so C#, F#, VB, and I believe that there is a community pull request open right now that will allow you to create infrastructure using Pulumi in PowerShell. We have the full CI/CD pipeline hookup, so we can build our packages, we can integrate with Spinnaker, Jenkins, CircleCI, TeamCity, Azure DevOps, Travis, CodeFresh, all of these different things. And of course, I told you already that we can interact with each of the provider environments that we said. So let's get into the details of actually why infrastructure as code and infrastructure as software is correct. So Pulumi is end state, okay? It is a declarative syntax, but because it's in an application, like a programming language, it's done in an imperative way. So how we actually get to the declarative state is up to us. We can refactor it, we can have classes, we can actually build our relationships ourselves, but how we specify is actually the endpoint. Here you will see that we are specifying a security group and an instance, and we are declaring a direct relationship between them using the VPC security group ID. So there's a lot of things going on in this place. Now, we can take advantage by default of using conditions and loops because we are using the actual languages themselves. We haven't had to shoehorn anything in. We haven't had to build our own logic layer or anything. We can take advantage of it. So here you can actually see that you'll create public subnets only if they're required. And then not only that, you can take advantage of a map, so that's the equivalent of a loop when you actually need to do that. We have full multi-provider workflows, and this starts to allow you to do much more interesting things like lazy registration of providers. Now, what that means is that you can start to manage your application code in the same project as your infrastructure code if you so wish. So you can build your Kubernetes resources, and the output of your Kubernetes cluster would be a kube config that, of course, you can specify and build in your own way. And then you would push that output into a Pulumi provider that would allow you to interact with Kubernetes. Because we work on promises, and we understand that the promise will be fulfilled. Otherwise, the application will actually fail. I told you about packages before. There's not really a lot to say about packages, but of course, the nice thing about packages is that they can be versioned correctly, and you don't actually have to take a new version of the package if you don't need it. And you can actually have an infrastructure management team building your packages for use by your engineers themselves. Now we really get into something that I love about Pulumi. The advanced orchestration side of Pulumi makes it for me one of the most fun tools to use. So here is a piece of code that does the following. We have an existing Kubernetes cluster. We want to deploy 3 versions, 3 replicas of our application as a canary to that Kubernetes cluster. After we deploy those 3 versions, we can talk to Prometheus, check that our Prometheus metrics are working as expected in our application, and then once we're happy, we can continue deploying the rest of the replicas in the cluster. Now, how can we do this? We can do this because of the fact that we are real code. Because we're real code, we can ingest packages that are already on the internet. So there is a Prometheus package in NPM that allows you to interact with Prometheus. The check app metrics class is just a class that wraps that specific interaction with Prometheus and returns a bool, true or false. Now, once that's actually the case, it allows you to do anything. So you could very easily swap out Prometheus there, and you could get it to talk to any other tool that has a package or an API that you can talk to. We believe that we're starting to get into the era that people not only need to build proper infrastructure code, but that they also need to test infrastructure code. And one of the problems that a lot of people have had about testing infrastructure code up until now is that it's very slow to test. So an example would be if you needed to test that your code for an Amazon EKS, so Kubernetes cluster, was fit for purpose, then it actually takes in the region of about 20 to 25 minutes to spin that cluster up. And then you would be able to test that all of the inputs that you gave that's there. Now, we've sort of thought this through on a different level, and we've said, hey, you know what? If we're doing this, we're actually only really testing the cloud. So we're only testing like what we're passing into the cloud itself. We know that if we pass a well-formed request, Amazon will give us a well-formed response. So we can actually mock that interaction, and we can understand based on the inputs in your Pulumi application if it's actually going to do what you need it to do, rather than spinning up the cloud, waiting on it to be provisioned and then destroying it again, which means that you can run these specific infrastructure tests in seconds rather than in minutes or hours, depending on how many that you have. We have a use case actually that someone in our public Slack channel, so we have a Pulumi community Slack, said that they were running hundreds of infrastructure tests, and it used to take in the region of 70 to 80 minutes, and then they actually reduced them to a number of seconds. It was like 27 or 28 seconds to run all of their infrastructure tests, and they were extremely happy with this new feature. But my favorite feature of everything in Pulumi is secrets management. Now, we are inherently bad at secrets management in IT right now. We have seen so many problems throughout the industry where secret management has gone wrong, and therefore we have leaked infrastructure, or we've checked secrets into source control, or even we haven't really secured anything and we're putting insecure infrastructure on the internet. Now, of course, for me, this is extremely painful because I try and profess everything I do, and it's try to be what I do on a day-to-day basis. And usually with your infrastructure tooling, you would have to have multiple tools working in combination in order to get a very good secret management story working as expected. Now, Pulumi has a secret engine built in, and we're trying to show people that this should be something they think about from day one of their infrastructure. So we by default, if you use Pulumi, it uses something called Pulumi KMS, which, because Pulumi is hosted in Amazon, we will give a specific KMS key for your project and your stack, which we'll talk about in a little bit, and we will encrypt the secrets that way for you. But you don't need to use Pulumi KMS. You can use your own KMS key. You can use Azure Key Vault. You can use GCP KMS, or you can also use HashiCorp Vault. Okay, we don't mind which one you use. We just want you to actually use a secret provider as built by your application as we go. Before we get into actually looking at a demo, it's really important to look at how Pulumi works under the hood. So we have a Pulumi CLI, think of it as a client. It runs on a machine, whether it's your machine, whether it's a CI machine, whatever, and it will read the credentials from that machine. The CLI will interact with your cloud of choice, and once it gets a response from your cloud of choice, it will store the state by default in Pulumi.com in the Pulumi SaaS. Okay, you don't have to use the Pulumi SaaS. You can log into an S3 backend or an Azure Blob backend or a GCP storage backend or anything. So there's a number of different backends that we support, but it's really important to say that Pulumi.com or your S3 bucket does not communicate directly with the cloud, and also no credentials are actually ever transferred back to your storage. So even if you leak your state file, which is an extremely simple state file, then there are no credentials stored in there by default unless you specifically inject them as raw text variables. So we can look at some of that in a little bit. So let's go and have a look at some code, because it's easier to look at code for this than it is to do for anything else. So I'm going to make a directory. Actually, we can just Pulumi. So Pulumi is a CLI. And by default, when I run Pulumi, I will get a number of options. Okay. So, and what it does is it says You can run the Pulumi command, which we'll look at in a second, but the most common commands after that are up, stack, config, and destroy, and we're going to look at all of these as we go through. So by default, Pulumi is interactive. So if I say Pulumi new, it's because I have an ID file in there. I can say Pulumi new, and it will give me a list of templates that I can use. It's predefined, pre-built templates that are all actually will allow you to start up and do everything you need. So today we're going to choose AWS TypeScript, and it's going to ask me for a project name. DevOps 2020 is perfect. A description, okay, because sometimes you want to give a little bit more meaning about what a project is, and it will ask me for a stack. Now, it's important to note here, we force you to think in terms of stacks in Pulumi. A stack can be an environment. So you can have a dev stack, a test stack, a staging stack, a production stack. But a stack can also be for an individual developer. So dev 1, dev 2, dev 3, dev 4, dev 5. And all it is a segmentation of state. It will all use the same base Pulumi application, but you can run Pulumi up, Pulumi destroy independently of each other and not actually affect other infrastructure within the space. So it's a really, it is just a representation of a state for a specific use case. So, and an environment is the best way to think about that. So dev is fine today. And lastly, it says, which region, because I know I'm going to go into AWS, so I'm going to say US West 2, just because it's my region of choice, and I know that the demo works in US West 2. Now, it's JavaScript, and it will just take a few seconds just to install all the plugins that it needs, because it understands all the plugins out of the box that it does. And right now, we have a fully defined project that we can have a look at. So it has a git ignore file. IDEA is my terminal, or excuse my IDE file. Pulumi.dev.yaml is a specific YAML file with configuration for the dev stack. Now, if you had multiple files, you could all have them all in here. Pulumi.yaml, you don't need to worry about right now. Index.ts, which is actually like the application itself. The package files, because it's JavaScript based and it needs to actually install packages. And lastly, it has a TS config, which tries to enforce real ways of working. So let's have a look at what it's doing. Now, by default, it will give you the most basic resource that you can do within a specific environment. So there are 3 segments to it. Firstly, we have some import segments. Now, it's important to notice these as our helpers, okay? So Pulumi allows you to have helpers to actually Pulumi itself. So config classes, stack references, so that you're actually talking between stacks and so on. Then you have AWS, which is the base layer of providers. And then lastly, you have AWS X, which is the crosswalk stuff that I said about the helpers and the patterns to make things better. So then we declare a simple, we try and give you the most basic resource, and we always think that an S3 bucket is a super simple resource that you can get up and running with. And as you can see, my IDE is actually giving me full documentation and telling me everything that it actually needs. So we try and segment it into namespaces. So if I say AWS dot, I will see auto scaling, IAM, EC2, EKS, ACM, ALBs, App Mesh, App Sync, Athena, Backup, so on and so forth. Today, we're taking advantage of S3. And then inside S3, we have other resources. So we have bucket, access points, bucket metrics, bucket owners, bucket, all of these different things. So every class that is represented in the AWS CLI and SDK is also represented in a similar way in Pulumi. Now, a resource itself, of course, look, I've just taken advantage of the ID and I've just stepped into the code and stepped into the API to understand what it has, but it has a name, it has some optional arguments, and it has some Pulumi custom resource options. Now, we'll take advantage of Pulumi custom resource options in a little bit because they're really important. And we want to get into that space in a second. But we can just see right now, we're just taking advantage of the name. And then lastly, we are taking advantage of exporting the ID of the bucket name. So if I run Pulumi up, what Pulumi will do is it will tell me what changes it needs to make. Firstly, it needs to create the stack. Okay, it needs to, because it doesn't exist, it's a brand new stack. And then it's going to tell me that it's going to create an S3 bucket. And I'm really hoping, there we go. So, and we can actually have a look at the details. Now, as you notice, it's again, it's important to say by default, it is it is interactive. Okay, you can switch that off, but we don't need to now because it's good for what we're trying to see. Now, the details will show you that the bucket that we're going to create is actually my bucket dash and then a random name, a random string. Now, the issue here is that Pulumi believes that we need to support high availability in the cloud. And there are a number of options in the cloud, including S3 buckets, where you cannot create a new bucket of the same name. You need to create a bucket with different names. So we try and force you to do auto naming so that you can create a new version of your infrastructure before you delete your old version of the infrastructure. Now, of course, we can turn that off, okay? Because if I go back and I take advantage of the bucket argument and I say bucket, which is the name, and I can say DevOps, 2020 stack 72. And I go back to my Pulumi up again, and it will now give me a strong name, and it will tell me exactly that it's going to create a bucket with the name DevOps 2020 stack 72, and it'll just take a second. And there we go. We can see the bucket name is a forced explicit bucket name, of course, and we can say yes, we can roll the bucket out, we can change it, we can do all of the same sort of interactions that we would do with a tool like Terraform, for example, where you have the CRUD, it manages the state, it saves the state, as you change, it goes through, and everything we do. Now, there's a really great question right now is around managing drift. So it says with Terraform, you define resources and how they're connected, and you get the full graph of your infrastructure. Over time, the state that's described in the repo tends to drift from the reality for various reasons. So changes on the provider side, changes on the different thing. So how can Pulumi help with that? You know, how can we manage the drift between the different processes? So by default, Pulumi will never run a refresh. It's maybe a bad decision that was taken by the engineering team. It's something that we're actually looking at right now. But Pulumi refresh will always give you the refreshed state before you do anything. And if I run Pulumi refresh, it will list all in my UI or my my CI pipeline or my terminal, all of the drift that has happened with the code. And of course, you can then bring that in. You can ingest that by saying, yes, update the state. Then the next application will overwrite it, or you can actually choose to ignore that. So it's state is one of those things. It's a discipline of infrastructure as code, because if you're not disciplined and you have an initial rollout using an infrastructure as code tool, then there is a potential that you can actually like kill your own infrastructure as you go. So you have to be disciplined as you go through. Sergey, I hope that answers your question. If not, please join me in the Zoom afterwards and we can get into more technical detail on it. So let's do something more interesting. Okay, let's start to build some proper infrastructure. So the first thing that we want to do is we want to go off and get an AMI, okay? So we have a data source, and I have to wrap it in Pulumi.output because it's asynchronous programming model, and I actually need to force a synchronous program, okay? Then we can, don't worry, this is a fake key pair, so please don't try and use this key pair anywhere. Then we can declare a security group. And then lastly, we can actually start to build some information. Okay, so let's pretend that I have to create 100 web servers. Now, this is why I love JavaScript and also hate JavaScript. Because what I can do in JavaScript is have an empty, unbounded, untyped array, and I can say, let web servers just be this empty bucket. And then I can say for let x equals 0, x is less than 100, x plus plus. Like I just written the most simple programming loop that you can imagine. You just format the code a little bit just to make it a little easier and a little nicer to see and nicer to read. And then now I'm inside the loop. So what you would usually do is you would say const, it's JavaScript, I would say server equals new aws.ec2.instance, excuse me. And we need to give it, every resource needs a specific unique name. So we can say web server dash X. So it'd be web server 0, web server 1, web server 2, etc., etc. And then we need some arguments because look, our ID is telling us right now that that's not enough arguments required for an instance. So what we can say is we need an AMI. We know we need an AMI in Amazon, so I can say ubuntu.id because Ubuntu is from above. It's telling me again, it's still missing some more parameters, some more things. I'm going to say I need a key name. And the key name will be sshkey.keyname. I need some VPC security group IDs. I know that because we actually need to access the server itself. So we'll say open security group.id. And lastly, we need an instance type. Now, magic strings are the bane of most people's existence because you need to probably go and have a look at exactly what it's doing. We've given you a way of being able to do this. So we can say aws.ec2.instance types and then we actually get all of the autocomplete for all of the current instance types. Today I'm going to just use T3 small just because it's nice and simple and easy. Now, what we would usually have to do is we'd have to say web servers. We'd have to push that onto the web servers, but we don't need to. We can actually say web servers dot push new AWS instance. And then we now have a collection of EC2 instance types. And I can take advantage of that because I can say export let public IPs, because we actually care about the public IPs. And I can say web servers.map. And then I can take advantage of a small lambda x.public IP. And that will list, it will build 100 web servers and it will give me back all 100 IP addresses in a collection called public IPs. Now, let's refactor this a little more, okay? So let's create a file called webserver.ts. And I need to take some code in. So the first thing I need to do is I'm going to take my SSH key in because sometimes you don't want developers to have to create their own SSH keys. You don't want them to give them that, that you want to use a predefined key that is managed by ops, if you will, or anything like that. And then now what we can do is we can say export the class. I need to increase the font size. I apologize. We'll call the class web server. Okay. Now the class will return a VM, which is of type AWS EC2.instance. Now, a class in TypeScript requires a constructor, and we can say name string. We can say AMI ID, which will be Pulumi.input. And we'll come back to that in a second about why that's actually the case. And lastly, it needs an instance type, which will be aws.ec2.instance type. We have defined our own class right now, and we can do whatever we want in here. So I can say this.vm. So the instance of VM to return is a new AWS EC2.instance. And we'll call it web server. Actually, we'll just call it name. So just to, because people are specifying a name in the constructor, then we need an AMI, and our AMI will be AMI ID. We will have a key name, which we already know in the class will be sshkey.keyname because it's above. We can say VPC security group IDs, which will be opensg.id. No, excuse me, a typo. And then lastly, I can say the instance type will be the instance type. Now, that is a very simple, very simple representation of a small package that within your organization you could wrap up and you could put out on your company NPM registry or Pipey registry that would allow people to start to take advantage of building instances. Now, how do they ingest this? Instead of a new EC2 instance, we can push a new web server. Now look, my IDE has immediately brought that web server class in because it knows that it's there. And a web server would be, I'm so sorry, web server dash $X. So we're keeping the same name structure as before. Now we need ubuntu.id. I told you I would explain this. So Pulumi works on promises, and because it works in promises, it uses inputs and outputs. So output is something that is only resolved at application runtime. So therefore, an output is actually a representation of what comes back from a resource, but it is equal to the new input of what it goes in as before. Now, if I change this to string, you would see in my application in a second that you wouldn't be able to do this. So ec2.instance types. And T3 small. Now, what it actually tells me, this is because of the synchronous programming model, an output of type, an argument of type output is not assignable to the arguments in what we're trying to do as a type string. So what we actually could do is just go in here and just wrap it in a Pulumi input, and the world is a happier place. Now, our IDE has also told us that there's no such thing as public IP on the web servers class, because web servers is not a collection of web servers. It is a collection of the web server class. Web server class has a VM. So then we can public IP it. And that's how we actually do it. So we've been able to build using loops. Then we've actually been able to segment code and wrap it away. Very simple demo that I hope you can see the power of what we're trying to achieve. So let's go and look at something actually you can use today. Secret management. I'm going to install a package called random, which is literally just a way of creating random data. And it will allow me to do a lot of different things, okay? So I'm going to go back into my code. I'm going to delete web server. All this code will be available at the end, by the way. So I promise I will share it. My slides are also available so you can follow along. I'm going to say import star as random from at Pulumi/random. And then what I want to do is I want to say password. I want to create a new random password. Okay, so let's create a random password, demo1. And the random password, in order to be quite good about what we're doing, it would be length 30 and it would have special characters, okay, because we try and be secure. And then we want to export password1 value, constant, I apologize, equals password dot, I know it's stored in the output of the API is called result, okay? Now, if I go back and I run Pulumi up, then it's actually going to tell me it's just going to create a random password and nothing else, okay? Now, the issue is, and this is where a lot of tooling today in the industry leads us, is that if I say yes, we've created a random password, and now we have a password value that is in our output, but also in our state file. Now, of course, we never want that. We absolutely do not want to litter our state files with any secret values whatsoever. So let's copy that. Let's call it password2 and demo2. And we can take advantage of the Pulumi custom resource options. And this is where I told you that we have a secret engine. Okay, so we have additional secret outputs where we can map any, and I really mean any, of the outputs of a resource as a secret. So the first one, it's stringly typed, so you'll have to apologize for that. Maybe that's going to change in the future to make it a little nicer, a little bit more usable. But what we want to do is we want to encrypt result before we export it. So if I say password2 value, password2.result, and I go back to Pulumi up, Now, just to say, I can say yes, and I can say skip preview, which takes it out of interactive mode and like just runs as a raw CI style tool, and it won't do anything. It won't give me an update of what it's going to do, but you will see that it will create the new password and it creates a secret. Now, usually what this could mean would be that it's encrypted as it comes to the UI, but is stored in the state as a raw value. But no, you will see that we actually store the ciphertext and the hash. It's not a hashed password, it's the ciphertext and the hash of the name of the field that we're actually using in order as part of the state. So even if you check the state in, unless somebody has access to that KMS key that created this, it is not actually usable. And then just to show you one other thing that goes with this, I can actually say, maybe we want to encrypt the length and whether it has special characters so that anybody who does get this, they won't try and like attack it or brute force it or anything. You will see that no resources have changed, but you will see that it has updated the state file with all of the new pieces of information that it requires. So there's the hash or the secure representation of special, the secure representation of result, and the secure representation of length. So I could go the whole way down this class and I could encrypt any specific single variable that I want. Now, the other way to specify variables is via your stack configuration file. So if I Pulumi config set, and I want to say my root database password, and I just say it's password 1234, and I ran it like this, this would allow me to interact with my root database password within my Pulumi application. Now, of course, we haven't told Pulumi that this is a secret value, so it is stored in plain text. But I can run the same command with --secret, and it will encrypt that value, and we can now see the secure representation of that. Now, it's important to note one thing, okay? Let's just prove that it is kept as a secure value the entire way through and that nobody can start your application and read the password out to plain text. So I'm going to say equals new config. So we have a pulumi.config, okay? And then I'm going to say const db password equals config dot require secret, and the secret name that we actually called it, my root database password. And then lastly, I want to export that value equals just to show you that it actually comes out as the correct value. And then I can say again, Pulumi up, yes, skip preview. And we will see that it comes out as a secure value. And then lastly, if we go and have a look at our outputs, we can actually see that there isn't like the DB password value is actually kept as secure in your state file as you need to go through. Okay, running out of time. So let's go and do something a little more. Okay, let us go and do IAM. Okay, IAM is predominantly difficult only because of the fact that it's usually JSON that's used in lots of different places. If this conference was in person, I would usually offer a prize for the person who can tell me how to construct in JSON an assume role policy for an AWS role. So it's not as fun online. I can say new aws.iam.role, and it's my demo role. And then in here, you would say an assume role policy, which you would usually do JSON.stringify or something like that, or like a here doc style scenario or something like that. Pulumi has created a helper, which can say aws.iam.assume role for a policy. The policy will have a service, and the service will be ec2.amazon.aws.com. Now, if I run a Pulumi up, and I skip and look at the preview, then we will see in a second that this will create a correct JSON specification of the assume role policy. And it will output that as part of our state. But of course, our application is still using the non-JSON state. So it's one of those things that no JSON should be harmed in the making of your resources, because we are not computers, we are people. And because we are people, we deal in real things, not JSON itself. So we can see that it's all there as expected. Now we can take this a little further. What happens if we want to attach some extra policies to that role? And I'll say that usually our policies look like this. Again, these are painful. So we have aws.iam.managed_policies. Let's give it administrator access, or let's give it container registry full access. Okay, instead of read only, we'll take that one away, because let's pretend this is for AKS. And we can say let count equals zero, for const policy of managed policy, ARNs. Okay, so for each string in that list, you want to create const RPA equals new aws.iam.role policy attachment. And we're going to say it's my RPA $count++. And lastly, we can say it has a policy ARN, which will be the policy. And it has the role, which will be the role. Now notice that again, no JSON was actually used in order to do everything that we do. And the last thing that we try and show when we're talking about IAM roles is for actual policy documents themselves that get specified on buckets. So let's pretend that we have a bucket as follows. Okay, and that bucket needs a policy that allows just get bucket and nothing else. So I can actually say const my policy, which is of type aws.iam.policyDocument equals, and let's create the class. So firstly, it says the version, and the version, it only gives you two valid options. If you get that incorrect, Pulumi will complain and say, that's not a valid version for a policy document. So let's create that back to 2012. Then we're going to say that it needs a statement, or a collection of statements a policy can usually have. And a statement can have a SID. We'll leave it empty for now. It can have an effect. An effect can only be allow or deny. So let's say deny. And let's say the printable, let's say for everyone. And the action would be s3.put object. Okay, let's restrict putting objects on this policy. And lastly, we can say the resource, let's just say everything for now, just because I don't want to type it all out. This will be pointless. And then I can say policy is my policy. And that is a valid policy. So you don't need to adhere to doing different JSON and different pieces. That's all there. It makes life a little easier. So I promised you an idea of how you would create an AWS VPC with all the different pieces that go with it. So usually you would say VPC equals new aws.vpc, ec2.vpc, and then from there you would say aws.ec2.subnets and internet gateways and all of these different things. But to do that, we can say new awsx.ec2.vpc, and we'll call it my demo VPC, and it just needs empty arguments. Actually, let's specify a CIDR block. CIDR block can be 10.0.0.0/16. Let's make it a supernet. And if I go and run Pulumi up right now, first thing it's going to do is it's going to remove that role, and that's okay. And we can see it's creating the VPC, it's creating the subnets, it's creating a NAT gateway, the internet, the elastic IP that goes with the NAT gateway, the internet gateway itself, and it'll specify that it has to create the routes, the route table associations. Now, as people are starting to take advantage of the cloud. And you'll see that this is actually, these are all created. Like these are running right now, and you can see that it's actually deploying all these pieces of infrastructure. As people are starting to take advantage of the cloud, there are lots of pieces of the cloud that they don't know, okay, that they not even know, but that it's difficult for them to understand that it's required and all these different things. Pulumi can make this super easy for you by doing exactly this. It will give you the ability to create multiple pieces of infrastructure, just wrapping like everything that it needs to do. So if I extend this a little further, okay, so what I want to do is I actually want to deploy an ECS cluster into that VPC. So I can say const cluster equals new AWS X ECS cluster. Okay, the cluster will be my demo cluster, and I can actually specify the VPC that it needs to be created against is that entire VPC object. I don't need to know which part of it. I can pass the entire object. And then based on that, I can start to do more interesting things. So let's pretend that we need an ALB in that VPC. I can say ALB equals new AWS X dot elastic load balancing v2 dot application load balancer. Oh, excuse me. And it's my LB and I'm just going to then say I want it to be external. True. I want it to have security groups, and the security groups would be the cluster.security groups, because by default, if in the ECS cluster, if you don't specify security groups, it will create some for you. Lastly, I want to say VPC will be VPC. Then we want to create a listener on that ELB. And this is where the power of TypeScript takes over, because I can say constant web equals ALB on that application load balancer dot create listener. So I'm using an extension method to create a listener, and the listener would be called web. And I want that to be port 80. And I want that to be external true. Of course, then I can say the VPC as well, but of course it'll inherit it based on the ALB from above. And then let's create a Docker container here. So let's create a new folder called app. And inside app, we are going to create the following. Okay, so the first thing that we do is we are going to create a requirements.txt file. Okay, so it's a Python app. Okay, the only two requirements are it needs is Flask and Redis, nothing else. And then based on app, we can then turn around and say we need an app.py file. Okay, so we need an application file itself. And we can say app.py. I can paste all of like, look, you're connected, here's your host name, here's the visit, so on. It's a very, very basic application, but it just shows you exactly what we can do. And lastly, we need a Docker file. So based on the Docker file, we can build and interact with Docker as part of our Pulumi application. So at that point, I can say, let's build a Pulumi image. So I can say this. I can say, image is an image from the path using this folder. And what it will do, ECS image will actually interact with Docker on my local machine to build a Docker image, and it will push it to a place that I suggest. And lastly is let's actually push it to somewhere where I suggest, where I can say that it is here. So it will go in the Fargate service, and let's say subnets, which will be VPC dot public subnets. Oh, public subnet IDs. I apologize. At that point, we're actually taking an entire artifact, a promise of an artifact from a local machine going through Docker, deploying it to Fargate in a cluster of our choice and everything we do. So if I actually say Pulumi up, just to show you what it's going to do, and it's going to tell you it's going to do a lot more things. I hope this doesn't fail because this will be silly looking otherwise. And you'll see it's going to create a lot more things. It's going to create 32 new pieces of infrastructure. It's going to create the ALB, the target group, the listener, the egress security group rules, the ingress security group rules, the load balancer itself, the cluster, the Fargate task definition, the ECR repository where you're going to store the image, the IAM role that goes for it, the CloudWatch log group, the ECR life cycle policy. It's going to do all of these different pieces that's required. And if I say yes, then it would actually go and build those as it needs. I'm going to say no here because this will be a much slower way of doing it. But of course, you can see right now that it's going to interact and build your Docker container as you go. So there's a lot of different things that you can do there. Now, and there's the last one that I want to show you. I could get into I could get into EKS like Kubernetes today, but that would take up an entire sort of system. Let's pretend that we want to create a serverless app. So this is for the developers out there who are like serverless people and serverless fans, and they actually want to create a Lambda and hook that Lambda up to an API gateway. So you would usually need the Lambda, the API gateway, the permissions, the Swagger doc, all of the different glue pieces that work together in API gateway. So let's pretend that first thing we need to do is create a DynamoDB table because our application, our Lambda needs to talk to DynamoDB. Okay, I need to then, I can just copy the code and explain what the code is doing. So we're going to create an API gateway, and the API gateway will have a list of routes. The first route on the path of / it will be a get, and the event handler will be all of this code inside the event handler. Now, what Pulumi is clever enough to understand is that it will resolve the differences, the dependencies, because the first thing it does is it knows that it needs to get the DynamoDB AWS SDK. Okay, then it knows that it needs to get that table name that we created, the counter table, the DynamoDB table, and because of the promise, it will resolve that before it actually deploys the Lambda. And then it will actually understand that when something hits that API gateway endpoint, it will invoke the Lambda, and the Lambda will be able to talk to that API gateway table. Now, if I do this, and I Pulumi up, if I Pulumi npm install AWS SDK, because I actually need the SDK on my machine. And then lastly, I can export the URL so that we can actually see the URL of everything that it's doing. So if I Pulumi up, I hope I haven't crashed my Pulumi application right now. Should be okay. There we go. It's going to create all of these different pieces. Oh, I need to delete the other pieces. I apologize. I'm sorry. We got up to creating the cluster. It's fine. There we go. So let's run the Pulumi up. And now it will tell me it's going to create the DynamoDB table and the API gateway, AWS X package, and all of the required pieces under it. So the role policy attachment, the function, the REST API, the deployment, the permission, the stage, all these different things. If I say yes, then it shouldn't take too long to deploy this specific service. Please don't take too long. I'm running out of time extremely fast. Last piece, I believe, just the stage after this one. Come on. There we go. So we have a URL that we can actually interact now with our Lambda, and I can curl an endpoint and I can say DevOps. I'm hoping we get an output. Please give me an output. Please make sure my Lambda is correct. And we'll see anytime that root DevOps was hit, the count. Of course, that's storing in DynamoDB. If I hit it again, we'll hit it 3 times. We can hit it 4 times. Doesn't matter. I can change it because of the way the get works. I can actually change it to 2020 is crazy because it is a crazy year. And we can see that it's storing all of that information in our DynamoDB table. I am going to open up to questions now because I have thrown a lot of information at you very fast. And I believe there could be a few questions. Vladimir?
Yeah, thank you. There is a question from Artyom. And the question is, well, there is a special SDK from Amazon. And the question is probably like, what do you think of a cloud provider universal SDK? Is it something you are planning to implement or vision? So what's your vision on cloud agnostic SDK?
So great question. There's a lot of different parts to this question. Okay, just to paraphrase, there is already tooling like this for Amazon, like the CDK is what it says, and it's extremely powerful. Now, of course, the CDK itself only emits CloudFormation templates. It doesn't do any of the state. It doesn't interact directly with the AWS APIs. Okay, Pulumi does. Pulumi actually doesn't emit CloudFormation templates or ARM templates or anything like this. Everything I've showed you today, I could replicate the same examples, of course, changing the resources themselves in Azure or GCP or any cloud that supports all these different things. So it's not that it's us versus CDK or us versus Terraform. It's a case of if, as part of your ecosystem, you need to use AWS and you have a team that uses a little GCP for like machine learning, but you also want to take advantage of New Relic or Datadog or Artifactory or any of these different technologies, then you would want a tool that's a little more agnostic to allow you to do all of these different things. Because right now I showed you Docker. Okay, usually the workflow would be is that you'd have Docker on your machine, you would build containers, you would push those up to a repository, and then you would need to reference those somehow into your application. We believe that that container is actually part of your application, so therefore should be built as part of the same application using the same workflow. So it's not that we're trying to create this cloud agnostic tool. Please don't take it that that's the case. We're trying to give people a very simple workflow that will allow them to do everything they need to do within the same workspace and the work environment. Does that make sense? Artem, I hope that answers your question.
Yeah, if it doesn't, please clarify in the chat as well. I think it does answer. Yeah, thank you. And well, can you please clarify the way parallelism works? It looks like the resources were created in parallel as you were running the script. And is it something in the language itself, or how it's controlled?
Oh, wonderful question. Okay, so Pulumi itself will try to do everything in parallel as it needs to. Okay, because it doesn't need to build this entire DAG, okay, direct acyclic graph, okay? It doesn't need to know that this actually is related to this and so on, unless you specify that there is a relationship between each of the items. So a perfect example would be in the last example that we actually deployed. So we have a DynamoDB table, and that DynamoDB table is referenced inside the API Gateway API. So it knows that the DynamoDB table is the first piece of information that actually needs to be deployed before the API gateway and all the resources that actually use it. If there was no hard-coded, see this direct counter table.name, that is a direct reference to counter table right here. It would actually try and do all of these things in parallel. So Pulumi will only do things in an explicit manner. So like, A, then B, if it's actually a requirement. Otherwise, it just works its way down the program as expected, if that makes sense.
Yeah, great. And what if there is a dependency loop in there?
Excuse me?
What if there is a dependency loop in there? Like two resources depending on each other. Will it fail at like compilation time or at runtime, or how does it behave?
It will actually fail at compilation time. So Pulumi will tell you at compilation time before it needs to do anything that it needs to do. This is why, like, specific things like if I spelt that wrong, okay, or like if I have a spelling mistake, if you had a JSON template or you had a YAML template, of course you could validate it, but you can't really validate it against the real schema, right? You'd have to actually bring the schema in. You would have to write like a program that would validate it. So like if we specified this in YAML and we had a spelling mistake in YAML, it's valid YAML and we would throw it up into the cloud. If I run exactly this in Pulumi, Pulumi is going to barf and it's going to say, hey, there's a TypeScript error here. It doesn't compile. And because it doesn't compile, it's going to actually tell me what the error is. You'll see it right there. Look, it might only reference known properties. Write opacity does not exist in the type. Did you mean to write capacity? So we're getting the power of the language ecosystem because this is not Pulumi giving us this. This is TypeScript. The same would be in Python. The same would be in Go. The same would be in .NET. We're actually using the compiler to tell us if the specified program that we are writing adheres to the SDK that we require. And also inside the table, we can see very, very easily in the table args, attributes is a required value because it doesn't have a question mark. Okay, it's not a nullable value, whereas billing mode is nullable because it has a question mark. You see what I mean? So very easily we're starting to build up a picture of what the API should be, and of course the compiler will fail if we don't adhere to the API.
Yeah, thank you for the clarification. And
sure.
What you show is infrastructure as a code approach. I wonder, what do you think of infrastructure in a code approach when you put something related to the infrastructure right in the middle of the application code itself?
Wonderful question. What do I think about a scenario where application code and infrastructure code actually like coexist in the same situation? Is that what you're trying to ask me?
Yeah, for instance, I create an application, and as you probably know, each and every application that is deployed to Amazon has to have some Lambda hidden there. And a Lambda is basically a single function. And what if I just put an annotation on top of my function telling, well, this should be deployed as an Amazon Lambda somehow, and dear framework, please figure it out for yourself somehow. So it doesn't really look okay. Do you get it?
Yes, I understand what you mean.
I mean,
I believe, so I said right at the start, I believe we're evolving into infrastructure as software. Okay, like even in the introduction that was given about me is like everything I believe is that, you know, we don't need to forget about the deployment of the application, how the application runs. It all needs to be symbiotic and actually work together. Now, unfortunately, there are a lot of teams who believe that still that ops have one job and devs have another job. And what we're trying to do is we're trying to give this idea that it doesn't need to be ops manage the infrastructure, dev manages the actual applications themselves. What we can do is we can say, right, this VPC layer, that can be managed by the operations people. Then based on the VPC layer that you have created, the operations people can export specific values that developers can get, like the VPC ID, the public subnet IDs, all of these different things. And then the application developers can actually base their development on top of that. So like they work much more together than separately, because what usually happens before, and I'm not talking that it happens in everywhere. It's just there are some places that haven't evolved into this idea that DevOps is a thing and that we all should work together to do everything. But it's very, very much a case of we can work together, and it shouldn't matter if there's application code mixed in with infrastructure code. It's about making sure that there's a good, repeatable workflow that both developers and operation people are happy with in order to do it.
Okay, great. Thank you. And Sergey asks, so what is your experience on the contribution to improving the standard library for Pulumi? So you described that there are lots of ways to implement your own resources in organization or in public. And what is your experience? Who is contributing the most to their standard library for Pulumi?
Great question. Really great question. So Pulumi is much smaller than other players in the game. Like really, we're a much smaller team even. We're a much smaller company. but we're growing extremely fast. Now, we currently do not support everything in the ecosystem, but what we have done, and we have made no bones about this, is that we have built a bridge project that means you can turn any existing Terraform provider into a Pulumi provider via automation. So what I mean by that is that there's a library that sits in the Pulumi GitHub org that you can go to, and you can run a couple of commands, scaffold it up, and you can build provider X based on what Terraform provider X was. So we've tried to not go and attack the entire ecosystem up front. So I believe, like at last count, there's like something like 260 or 270 different Terraform providers between official HashiCorp providers plus community supported providers. For us to take that on would be a crazy thing to take on. Whereas we want to give people the tools that they can do it themselves, and they can build their own providers on top. So I hope that makes sense, like what we're doing. With regards to the actual Pulumi system itself, we are completely a centralized generator. So every feature is available in all of our language SDKs, and that also happens inside the provider. So we focus much more on that side of it than actually implementing all the different providers themselves.
All right. Thank you very much, Paul, for the answers as well as for presentations with some demo. It was really amazing, and I'm kind of inspired by how you managed this with TypeScript, so I guess I will try it on later. Thank you very much, and thanks, Vladimir, for Q&A session. By the way, I remind you all that we will have discussion zone available in Zoom webinar link below the player. Please follow that one, and see you folks there. Bye-bye.
Thank you. Thank you.
Bye-bye.